Hey, what's up, calculus students? We're continuing on with 3.4 today, the acceleration, velocity, position stuff. And we're getting into more physics type ideas. So we're just going to jump into the examples here. We have two of them. The first one is modeling vertical motion. So the situation that they're giving us is that a dynamite blast propels heavy rock straight up with a launch velocity of 160 feet per second, which is about 109 miles an hour. There's a figure for it, but I'm going to draw it out. It says it reaches a height of s equals 160t minus 16t square feet after t seconds. So what it's saying is that, all right, if this is our height and this is our time, or maybe I shouldn't say h of t because it's labeled as s here, but you guys get the idea, s. Okay. What happens is anytime we have a blast or something propelled into the air, it goes up and eventually it comes down. So notice we do have a quadratic. Notice the negative 16, which means we have an upside down parabola. All this stuff checks out with those ideas from Alge 2 and Alge 1. All right, so it basically looks like that. It's saying that this is our function for our model for our height. So part A says, how high does the rock go? So these ideas are very, very important, and you'll see them come up over and over again. So what we're going to do is part A. How high does the rock go? What we know is, for a parabola, we have a vertex. And that's going to be the maximum or minimum height we ever reach, or value we ever reach. Now, using our calculus here, what we know is that, well, it's going to reach its vertex when our derivative equals 0. And we know that because the slope there at that point is 0, right? We said the derivative is the slope at a point. And we know that for any maximum or minimum value, the slope there, or the derivative there, is going to be equal to 0. All right, so let's do that. Let's find the derivative of 160t minus 16t squared. So the derivative of 160t is 160. And then we drop down the 2 times the 16 is 32t. We're trying to find when this is equal to 0. So let's go ahead and solve this. And then divide by negative 32, and we end up with t equals 5. Okay, so we know after 5 seconds, it's going to reach its highest point. And we know that because we said that when our derivative is 0, that's when our velocity is 0. Right? This is the position. So our velocity is 0. We could also say v equals 0. And that's because that's the point where it's transitioning from going upwards to now falling back down to the ground. Okay, so very important that we understand when we're looking for vertices, or our vertex, that we're looking at when our derivative is equal to 0. Okay, part B. Part B says, what is the velocity and speed of the rock when it is 256 feet above the ground on the way up and on the way down? Okay. So the first thing we need to do is plug that in to find when, right? Because this all revolves around t. We need to know the time when this is happening. So let's do... oh, that's going to be crappy to factor. Let's use our calculator here. Well, let's set it up first. So we're going to use the original function, right? Because we're trying to find t. So we're going to say that the s, because they're giving us the position, right? 256 feet is the height. That's our s. So we're going to say 256 equals 160t minus 16t squared. So the first thing we're doing is we're trying to find when, meaning the time, it's 256 feet up. Okay. Let's go back to my wonky little, my wonky little rig up here where I can show you my calculator. Ugh, let's do it this way. Okay, so you can see my calculator. We're gonna clear everything out and then we're gonna go to y equals. Sorry, it just keeps adjusting the focus. Okay, so we're gonna put 2, 5, 6. Oh, we'd have to solve that for y. Excuse me, so let's go ahead and do that. Oops. Let's go back. So let's just subtract 256. Oops. So this is going to look like 0 equals, I like to put it in order, negative 16t squared plus 160t minus 256. Okay. So we have negative 16. We don't have a t, so we'll just use our button for x squared plus 160 x minus 256. Okay, let's graph it. And then we're going to find our 0. So a little bit of practice here again. So what we can do is we can hit second, trace, which is calculate. So we're going to try to calculate the 0. And then we have to set up our boundaries. So we're going to kind of move our, oops, there it is. Move our cursor until we see it. So what we're trying to do is we're trying to find this intercept here. So I'm going to set up my left boundary. I'm going to set up a boundary to the right. Any place to the right is fine. And we're going to guess. And the 0 is at 2. Perfect. We could also, if our function comes out to a nice value for our intercept, we can also just count here. 1, 2, 3, 4, 5, 6, 7, 8. So we have zeros at 2 and 8. So let's go ahead and note that. So t equals 2 and t equals 8 is when it's 256 feet above the ground. Kind of running out of room, but let's figure this out. So we have the derivative function. The derivative function was 160 minus 32t. So we're going to plug this in. So 160 minus 32t is 2 here. So 160 minus 64 is 94. And then we plugged in the other one. 160 minus 32 times 8. I'm going to have to use my calculator here, but 32 times 8 is going to be 256. And negative 94. So it's symmetrical, therefore the velocities should be the same. Note that because our first one at time 2 is 94, it's going upward still. And then when it's coming down, the negative 94 at 8 seconds is negative because it's coming down. All right, let's move on to part C. It says, what is the acceleration? So remember, again, so we went from position to velocity by doing the derivative. So to get to the acceleration, we have to take the derivative of the velocity. So we have 160 minus 32. T is our velocity. We're going to take the derivative of that to get to our acceleration. So the derivative of 160 is 0. The derivative of negative 32t is just going to be negative 32. The t derives out to be 1. So what it's saying is the acceleration here is constant. It's not going to change over time. And it's probably due to the acceleration caused by gravity, right? It's always getting pushed back down. It's decelerating the whole time, if that makes sense. Because gravity is pushing down on it, which means it goes up. As soon as it goes up, it's starting to slow down, right? Acceleration means slowing down or speeding up. And then it keeps slowing down all the way till it hits back on the ground. Okay, so this would be part C. Acceleration is constant because there's no variable. Now let's go back to part D. And part D is asking us, when does the rock hit the ground? All right, excellent. So when does the rock hit the ground? So what we know at that point is, that's just a position, right? Position, yeah. So position equals 0. We're trying to find when it's equal to 0. And because we're using position, we're starting with the original function, which was 160t minus 16t squared. We're going to see when is that equal to 0. This one, we should probably just factor out our 16t. That way we get 10 minus t equals 0. We know that we're going to apply from Algebra 1. This is a zero product property. So if two things are multiplied and they equal to 0, then either 16t's got to be equal to 0 or 10 minus t equal to 0. So, well, that's easy. What makes that 0? 0. What makes that thing 0? 10. So we're not interested in this first one, right? That's the initial blast off for our rock or whatever we're looking at. We're more interested in how long is it in the air and when does it hit the ground. That would be after 10 seconds. So t equals 10. Because that's when it's back on the ground. All right, excellent. Let's look at this one, last problem. There's lots of parts here. So what it's saying is a particle moves along a line so that its position at any time t is greater than or equal to 0 is given by the function s of t equals t squared minus 4t plus 3, where s is measured in meters and t is measured in seconds. So what they're saying is, here's some line. And, well, I should use a different color for the particle. So here's your particle. All right, so this particle is just moving left and right along this line. Sometimes it's moving fast, sometimes it's moving slower, sometimes it might even be stopped. But it's modeled by this. So this is the position of our particle. So it can move left and right. It can't move up and down. It can't come off the line at all. So it's just going either positive is right or negative is left. Okay, so part A. It says find displacement during the first 2 seconds. Okay, so this displacement word might be new to you. What displacement means is how far it is from where it started. So how far from where it started. Okay. Let's use a different color to find this. Well, in order for us to know, then we'd have to know where we started at. So because we're using position, we're using the same form. S of 0 equals, and well, 0 t squared is 0. 4 times 0 is 0. So its initial position is 3. Okay, and then we'd have to figure out where it's at the end. So at the end of 2 seconds, that's going to be 2 squared minus 4 times 2 plus 3. So that's going to be 4 minus 8 is negative 4, plus 3 is negative 1. So it started at 3, it ended at -1. So the amount of change between 3 and -1 is 4. So your displacement, keep in mind, is always going to be a positive number because it's kind of like the absolute value of, right? We're not going to ask how far it is from the beginning and give a negative number. It's going to be given as a distance, and when we talk about distances, we talk about positive. Okay, so that's part A. Displacement, what we know is how far is it from where it started, and then from there it's pretty self-explanatory for the math. Okay, so for part B, it says find average velocity during first 4 seconds. So for part B, average velocity for first 4 seconds. 4 seconds. So that means from t equals 0 to t equals 4. And remember, we're doing average velocity, so we're talking about the slope between 2 points. So if we know where it started at, well, we do know where it started at, right? So when it was 0, it was at 3. We already said that's the initial position. After 4 seconds, though, we'd have to plug in 4 to our function. So we'd have 4 squared minus 4 times 4 plus 3. So because we ended up where we started, our change in y is 0, and our change in time is 4 seconds, this is going to be 0. So even though the particle did move left and right, overall, the average velocity, because it ended up where it started, is going to be equal to 0. That's pretty neat. Okay. Part C says find instantaneous velocity of the particle when t equals 4. Okay, so instantaneous velocity. So s of t equals t squared minus 4t plus 3. Remember, if we're talking about instantaneous, that means now we're going to do the derivative. So the derivative of this is going to be 2t minus 4. And then we just plug in 4, right? Because it's asking at time t. So that's going to be 2 times 4 minus 4, which is 4. So it's definitely traveling at t equals 4, even though the average velocity at that point would be 0. Okay, this is part C. Now let's get to part D. Find the acceleration. Okay, well, we know that the acceleration, again, right, it goes position, velocity, acceleration. So if we find the derivative of this, that should give us our acceleration. So derivative of 2t is 2. The 4 derives out. It's a constant. So this would be our acceleration. It's constantly accelerating at 2. Part E, describe the motion of the particle. At what values of t does the particle change directions? Okay, so this important thing here. When does it change directions? So it's changing directions. Let's make a note here. Change directions when the velocity changes sign. So it could possibly be any time where the velocity is 0. So remember, velocity, again, we're talking about the derivative. Velocity and derivative are synonymous, right? So when the derivative changes sign. So let's look at our derivative here. S prime of t equals 2t minus 4. When would that be 0 and change from being positive to negative? Well, it's 0 when t is 2, right? 2 times 2 minus 4. 2 times 2 minus 4 is going to be equal to 0. So it changes at t equals 2, right? Because if I have a time that's less than 2, like if I have a 1, then 2 times 1 is 2 minus 4. That's going to be a negative 2. So at that point, it's negative. Everything on that side of t equals 2 is going to be negative. Now, the moment that t becomes positive, like 3, for example, then 2 times 3 is 6, minus 4 is 2. So that's all positive velocity. That means that we're moving right instead of moving to the left. So yeah, we're trying to figure out when our times when our velocity is 0, and then determining, well, just because it's 0 doesn't mean we're changing directions. It might be that we stopped and then we're going again. But anytime we change sign as well on the left, from the left to the right, then we know that that's definitely changing directions. Okay, and then the last one, part F, is asking us, use parametric graphing to view the motion of the particle on the horizontal line y equals 2. We're not going to do that right now. We're not going to do the calculator stuff for that, so that'll be it. There's a lot that we've talked about, a lot of key concepts going forward. So hopefully we're going to do this more in the future. We're going to talk about this position, velocity, acceleration stuff a lot before the end of the year, but it's kind of the introduction to it. The more we talk about it, the more familiar you get with the relationship between those three functions, the better you get at it, and hopefully you get really comfortable at it by the end of the year. All right, good job.